All right, good morning from Forge. This is chemistry. So today I'd like us to proceed with the behavior we studied the other week. So this fashion is really great. So we're just going to look at some past paper, and this is from 2018, and that's May June, and it's paper 4. And I do believe by now you guys understand that paper 4 is the second paper, which is theory. So you're supposed to answer questions, all right, by explaining, by discussing, by suggesting answers, by stating, all that stuff just rolled into one. All right, so today we'll proceed with this paper from 2018, and as you can see, it's variant 1, so it's paper 4.1. And like I said before, so 0620 simply means the code for chemistry, and for physics is 0625. Alright, so we have some instructions. Always remember to follow the instructions. They're very important. Sometimes you'd be surprised to know that maybe the instructions say don't answer question number 10 or something like that. Who knows? Just take your time and read the instructions. It will do you great. More than harm. Okay, fine. So the first question says, substances can be classified as elements, compounds, or mixtures. All right, so that's just like an open statement. Sometimes it's there just to tell you that you're dealing with this topic about elements, compounds, or mixtures, whatever it is. Now, all right, so you're not supposed to answer that. It's just an opening statement. But if you go to A, it says, what is meant by the term compound? All right. So I remember we looked at elements, compounds, and mixtures. And we said that mixtures are substances that are physically combined. So there is no chemical combination in there, it's just a physical combination. And apparently if you want to separate them, you also have to use physical means. Means such as distillation, yes. Decanting, yes. What else? Filtration, yes. What else? Chromatography, yes, and many more. I think I gave you 10 separating methods. All right, now that's a mixture. What about an element? An element, we said, is a substance which is made up of only one type of atom in it. For example, if you talk about a sodium metal has only sodium atoms in the whole bar. Okay, if you look at an aluminium metal, that aluminium bar metal, what it has inside is just aluminium atoms. All right, making up the whole thing. If you look at copper wires, those wires that are used for cabling in the house, you can see that. You have to know that in those copper wires, the only type of atoms you have is copper. So copper atoms in there. So that's an element. Now a compound is a mixture. So this is a chemical combination of more than one type of atom. Okay. All right, one type of substance, sorry. All right, so a chemical combination, whereby if you have to separate them, you also have to use chemical means. And just to give you a heads up, one of the chemical means to separate compounds is known as electrolysis, and you look at that later, not now. All right, so we have examples of compounds like carbon dioxide. So carbon dioxide is a chemical mixture between carbon and oxygen. Those guys are chemically combined. You can't use distillation, filtration whatsoever to separate them. No, that's impossible. Another example of a compound is water, which is hydrogen and oxygen chemically combined. And you can use distillation, filtration, evaporation, decanting, whatever you know to separate those guys. No, that's just impossible. You have to use chemical means. Oh yeah, so I just defined the compound. So the chemical combination of more than one. So a compound is a chemical combination of more than one substance. So two or more substances. All right, here we go. It says B, mixtures can be separated by physical processes. Yeah, that's it. A sequence of physical processes can be used to separate common salt, that's sodium chloride, from a mixture containing sand and common salt only. Give the order and the correct scientific term for the physical processes used to separate the common salt from the mixture. Now, if you look at the mixture we have common salt with sand, Yep. So it's sand and common salt. So what are you supposed to do there? So we have to give a sequence of processes. So you have to give the sequence in the correct order to say, for us to separate these, you have to use this, and that. All right, now, the first step to do that is to dissolve the mixture of sand and salt. And you know what happens when you dissolve the two guys? What happens is that only salt will dissolve, but sand will not dissolve. Then after that, you're supposed to filtrate the mixture. So now you have a mixture of dissolved salt or salt solution and sand. Then you can just filtrate that. If you filtrate that, you see that the salt solution will go through the filter paper and the sand will be left behind on the filter paper. And the salt solution will be the filtrate and the sand will be the residue. Then after that, it simply means you have separated the salt from the sand, but the salt has water in it, so you're supposed to separate the salt from the water. How you do that? So many ways. Just evaporate it. Yeah, so just evaporate. So as you can see, so there are three processes there. The first one is dissolving, the second one is filtration, and the last one is evaporation. Good. Now it says the boiling points of 4 different alcohols, A, B, C, and D, are shown. So we have the alcohol there, A, B, C, and D, then you have the boiling point. So the boiling point of alcohol A is 56, the boiling point of 56 degrees Celsius, and the boiling point of alcohol B is 78 degrees Celsius, and the boiling point of alcohol C is 122 degrees Celsius, and the boiling point for alcohol D is 160 degrees Celsius. A student suggested that the apparatus shown could be used to separate the mixture of alcohols. Oh, really? Wow. This is some smart student. Alright, now let's go to the question. It says, apparatus X needs to have cold water flowing through it. So draw an arrow on the diagram to show where the cold water enters apparatus X and name apparatus X. Alright, okay. So the name for apparatus X is called Labie condenser. So it's a Labie condenser. And as for where water is supposed to go in and come out, alright, I'll leave that to you. You just go to the book and see where the water is supposed to come in to the condenser and go out to the condenser. So let me give you a tip, or the clue is that the water is supposed not to run down, just run down like that. It's supposed to go uphill. So, yep. Alright, let's go to question 2. It says, part of the fractionating column is missing. This means that the experiment will work. So draw on the diagram the part of the fractionating column which is missing. Explain why the experiment will not work with this part of the fractionating column missing. Apparently there are two things. You're supposed to have a thermometer and a stopper at the top of the fractionating column where you have the beads. So you need a thermometer and a stopper. When you don't have the stopper, the problem is that the gases produced from heating the mixture will proceed to the atmosphere. So you don't want the gases to proceed like that. You want the gases to go into the condenser and then into the collecting flask. Alright, so suggest why a Bunsen burner is not used to heat the flask. Oh man, I mean, you want to put heat there? Do you want to break the glasses or something like that? No, please. And apparently, these alcohols are very flammable. Do you want to set a flame in there? No, you must be kidding me. Alright, the last question says, a hot water bath cannot be used to separate alcohols C and D. Explain why. Now, if you go to alcohol C and D, you can see that their boiling point is above 100 degrees Celsius. And the boiling point of water is just 100 degrees Celsius. So apparently if you use a hot water bath, it means you won't be able to supply the required temperatures needed to separate C and D. Alright, so the total of that is 13 marks. All the best. See you next lesson. Have a good day.